Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practical 1 Volumetric Analysis. In the present module, we are describing experiment 10, that is determination of acetic acid content in vinegar. The contents of this module are brief mention about vinegar, aim of the present experiment, principle behind the experiment, reagents required in the present experiment, procedure of the experiment comprised of three parts. First part, preparation of standard oxalic acid solution, standardization of sodium hydroxide solution is the second part, and estimation of acetic acid is the last part. And finally, there is calculation and results based on these experiment. First of all, vinegar. You are familiar with vinegar, which is a very good preservative in homemade items, and vinegar is a dilute solution of acetic acid. And in the present experiment, we are going to estimate the acetic acid content in a given sample of vinegar. We can now have a discussion on somewhat more details of vinegar for the sake of convenience. Vinegar is a dilute solution of acetic acid with the molecular formula CH3COOH, which is dissolved in water. It is commonly used in cooking and preservation. A common vinegar sample contains 4 to 6% of acetic acid. This is the range of acetic acid, percentage of range of acetic acid in a given sample of vinegar. And our experiment, today's experiment, is to demonstrate how much amount of acetic acid is present in a given sample of vinegar. In the acetic acid content in vinegar is determined by neutralizing it with a standard NaOH solution. That is, acetic acid is CH3COOH, which is a weak acid. You can react it with sodium hydroxide, which is a strong base. So, in the present volumetric analysis, it involves a titration between a weak acid and a strong base. So, by utilizing the neutralization reaction between acetic acid and sodium hydroxide, it is possible to estimate the vinegar or the acetic acid content in vinegar. Now, why we have to determine the acetic acid content? To verify the quality or acidity level in commercial vinegar. Higher the acetic acid content, higher will be the acidity. Now, in food industry and quality control labs, this percentage of acetic acid in vinegar is important. Now, for titration experiments, we can also use vinegar. For that, we also require a knowledge about the acetic acid content in the given sample of vinegar. Now, aim of the present experiment. The aim of the experiment is very clear to you, that is to estimate the amount of acetic acid in the vinegar, and for this experiment, you are provided with N/10 sodium hydroxide solution and annular oxalic acid crystals. So, these are the two important reagents to perform the estimation of acetic acid content in vinegar. The reagents are N/10, that is 0.1 normal sodium hydroxide solution, and AR annular oxalic acid crystals. Now, the principle behind the experiment, that is now we are discussing the principle behind the estimation of acetic acid content in vinegar. AR oxalic acid crystals is used to prepare a standard solution. A standard solution means a solution with exactly known concentration. And by using this standard solution of oxalic acid, the sodium hydroxide solution can be standardized using phenolphthalein as the indicator. Here, phenolphthalein is selected as the indicator because you are performing the titration between the weak acid oxalic acid against strong base sodium hydroxide. And the pH range of this experiment selects phenolphthalein as the suitable indicator. And the reaction responsible for the standardization of sodium hydroxide by using a standard solution of oxalic acid lies here. 2 sodium hydroxide plus H2C2O4, that is oxalic acid, gives Na2C2O4, that is sodium oxalate, and 2 molecules of water. This is the neutralization reaction between sodium hydroxide and oxalic acid. For this purpose, to perform this reaction volumetrically, we are using phenolphthalein as the indicator. Oxalic acid is a weak dibasic acid and it is commercially available as its dihydrate. That is, oxalic acid dihydrate is H2C2O4 2H2O, and the equivalent mass of oxalic acid in its reaction between sodium hydroxide and oxalic acid is half of the molar mass. The molar mass of oxalic acid dihydrate, that is H2C2O4 2H2O, is equal to 126. That 126 divided by 2, you will get a value 63. That is, 63 is the equivalent mass of oxalic acid dihydrate. Using the standardized solution of sodium hydroxide, acetic acid in vinegar can be estimated. So, in the first part of the experiment, we have to prepare a standard solution of oxalic acid. By using that standard solution, we standardize the given sodium hydroxide solution, and using that standardized sodium hydroxide solution, we can estimate the acetic acid content in vinegar. A fixed volume of vinegar, the available vinegar, is diluted to a definite volume, and take a fixed quantity of that and titrate against standardized sodium hydroxide using phenolphthalein indicator. Again, in this reaction, this is a titration between vinegar, that is a weak acid, acetic acid, and strong base sodium hydroxide. Here also we are taking phenolphthalein as the indicator. Now, the reaction between sodium hydroxide and acetic acid present in vinegar can be represented like this. Again, a neutralization reaction. NaOH plus CS3COOH gives CS3COONA plus H2O. CS3COONA is sodium acetate. So, sodium acetate is the product. From the titer value, it is possible to estimate acetic acid present in vinegar. Most probably, this value is represented as a percentage. So, it is possible to find out the percentage of acetic acid in the given sample of vinegar. The equivalent mass of acetic acid in this reaction is a very important quantity, and you have to remember the equivalent mass of acetic acid is same as its own molar mass, that is equal to 60. So, equivalent mass of acetic acid is equal to 60, which is required for the calculations. Now, reagents required for the present experiment, that is the reagents which are necessary to perform the estimation of acetic acid content in vinegar. The reagents required are annular oxalic acid crystals, approximately 0.1 or n/10 normal sodium hydroxide solution, vinegar solution. This vinegar is used to perform the estimation of acetic acid. Now, the phenolphthalein indicator. So, these are the important reagents required for the estimation of acetic acid content in vinegar. We are now entering into the experimental procedure. The first part of the experiment is preparation of a standard oxalic acid solution. The mass of oxalic acid, which exists as its dihydrate, required to prepare 100 ml n/10 normal solution can be calculated by using the expression. Weight required is equal to VEN divided by 1000. V is the required volume, that is 100 ml. E represents the equivalent mass of oxalic acid dihydrate, that is equal to 63. And N represents normality of the solution to be prepared, that is equal to n/10 or 0.1. Substituting these values, we will get the weight required as 100 into 63 into 0.1 divided by 1000, that is equal to 0.63 gram. So, if you are weighing out 0.63 gram of oxalic acid crystals and transferred it into a 100 ml volumetric or standard flask and made up to 100 ml, you will get a solution with the concentration 0.1 normal. Now, roughly weigh out 0.63 gram of annular oxalic acid dihydrate crystals and transferred to a dry weighing bottle. It is then weighed by electronic balance and the weight of the sample plus weighing bottle is recorded as W1. The content or the substance present in the weighing bottle is now transferred into a 100 ml volumetric flask or standard flask through a funnel and make up the solution to the mark. So, you get a 100 ml solution. Now, the weight of the empty weighing bottle is taken and it is recorded as W2. So, remember W1 stands for weight of the weighing bottle and oxalic acid. W2 is the weight of empty weighing bottle. So, the actual weight of oxalic acid can be calculated as W1 minus W2. This weight, that is W1 minus W2, that is the weight of oxalic acid you are taken, is used to find out the concentration of oxalic acid solution by using the expression concentration, which is generally expressed as normality, normality equal to weight per liter divided by equivalent weight. Now, the second part of the experiment. This is the standardization of sodium hydroxide. For this purpose, we are using the standard solution of potassium dichromate we already prepared. So, a conventional titration procedure is adopted to demonstrate the experiment. 20 ml of the given sodium hydroxide solution is pipetted out into a clean conical flask. Add 2 drops of phenolphthalein indicator and this solution is titrated against the already prepared standard solution of oxalic acid which is taken in the burette. The end point is the disappearance of the pink color. Repeat the titration between the sodium hydroxide and standard oxalic acid solution to get the concordant values. Now, we are going to demonstrate the standardization of sodium hydroxide. Over to the laboratory. have conducted the standardization of sodium hydroxide, and now we have to perform the calculations to get the normality of the given sodium hydroxide solution. For this purpose, we are beginning the calculation from the weight of oxalic acid. The weight of oxalic acid taken is equal to the difference in weight, that is equal to W1 minus W2, which is equal to 0.6312 gram. Weight per liter of oxalic acid solution is obtained by multiplying this weight with the ton, that is equal to 6.312 gram. Here we are multiplying with the ton because of the fact that you are preparing the solution in 100 ml. So, weight per liter is the weight of the oxalic acid in 1000 ml. To get the weight in 1000 ml, you have to multiply with the 10. So, you got the weight per liter equal to 6.312 gram. Now, the normality of the oxalic acid solution will be obtained by weight per liter divided by equivalent weight, that is equal to 6.312 gram divided by 63. You will get a value 0.1002 normal. So, the normality of the standard oxalic acid solution you prepared for this experiment is equal to 0.1002 normal. Now, the titer values in the titration between oxalic acid and sodium hydroxide can be tabulated like this. Sodium hydroxide against oxalic acid is the titration. Volume of sodium hydroxide pipetted out is same in 3 titrations, and that is equal to 20 ml. In order to get to the concordant value, we conducted titration thrice, and we got the concordant value, that is the volume of oxalic acid solution equal to 20.1 ml. Now, from the titer values, we can calculate the normality of the sodium hydroxide solution using the relation NaOH into VNaOH is equal to N oxalic acid into V oxalic acid, that is the volumetric relation. And in the present experiment, we already got N oxalic acid is equal to 0.1002 normal. Volume of oxalic acid required is the or utilized is the concordant value in the titration, that is equal to 20.1 ml. And volume of sodium hydroxide, that is the volume pipetted out, which is equal to 20 ml. On proper substitution, we get the normality of the sodium hydroxide solution as 0.1007 normal. Thus, we standardized the given sodium hydroxide solution by using a standard solution of oxalic acid we prepared. Now, the last part of the experiment, that is nothing but estimation of acetic acid. Take 10 ml of commercial vinegar and dilute it to 100 ml with the distilled water in a standard flask and shake well. Remember, in all the preparation procedures and dilution procedures, we have to use the distilled water. Now, the solution is loaded in a burette. The diluted solution of the commercially available vinegar is loaded in a burette. 20 ml of the already standardized sodium hydroxide solution is pipetted out into a clean conical flask. Add 2 drops of phenolphthalein indicator. Remember, the suitable indicator for this titration also phenolphthalein. This is because here also you are performing a titration between the strong base sodium hydroxide and a weak acid. If acids are weak, the best indicator is phenolphthalein, since its pH range lies with the pH range of the solution at the end point. It is then, the solution is then titrated against vinegar solution taken in the burette. We already filled the burette with the vinegar solution, and you pipetted out 20 ml sodium hydroxide and add the phenolphthalein indicator and now perform the titration. And the end point of the titration is the disappearance of the pink color, and here also you have to repeat the titration to get the concordant values. Now we can demonstrate the estimation of acetic acid, the experimental part behind the estimation of acetic acid. Over to the laboratory.
Now take a commercially available sample of vinegar and transfer some quantity of
the laboratory part of the estimation of acetic acid, and now we can perform the calculation based on results obtained. The titer value can be tabulated as follows. This is the titration, that is sodium hydroxide against vinegar. The volume of sodium hydroxide solution pipetted out in 3 cases is 20, and you got that concordant value, that is the volume of vinegar solution used is equal to 22.6. Now, from the titer values, we can calculate the normality of the vinegar solution using the relation N1V1 equal to N2V2. This is the volumetric relation, and here N1 represents normality of the sodium hydroxide solution that we already standardized, and we got it as 0.1007 normal. Now, V1 represents volume of NaOH, that is the volume of sodium hydroxide pipetted out, which is equal to 20 ml. Now, N2 represents normality of the vinegar solution that we are going to find out, and V2 represents volume of vinegar, that is the concordant value in the titration, that we got as 22.6. On proper substitution, we will get normality N2 of vinegar as N2 equal to N1V1 divided by V2, which is equal to 0.1007 multiplied with 20, the whole thing divided by 22.6, you will get a value that is equal to 0.0891 normal. This is the normality of the prepared vinegar solution. The strength of acetic acid in diluted vinegar. We take a fixed quantity of vinegar and dilute it. So, the normality of acetic acid in diluted vinegar is equal to normality into equivalent weight. That is, normality of the diluted vinegar we obtained as 0.0891 normal. Just multiply with the equivalent weight of acetic acid, that is equal to 60, you will get a value that is 5.346 gram per liter. Now, strength of original vinegar, that is we require the strength of original vinegar we taken for the experiment, that is undiluted vinegar concentration should be calculated. Since during the experiment we dilute vinegar 10 times, that is we took 10 ml of vinegar and made up to 100 ml. So, there occurred a 10 times dilution. So, strength of original vinegar is obtained by multiplying the concentration of diluted vinegar with the 10, or the weight of diluted vinegar per liter multiplied with the 10, you will get the original concentration of vinegar, that is 5.346 multiplied with the 10, you will get the weight per liter of the original vinegar provided, that is equal to 53.46 gram per liter. Now, the percentage of acetic acid in vinegar can be calculated as percentage, that is weight by volume percentage, is equal to 53.46, that is the weight per liter. So, weight per 1000 ml. So, 53.46 divided by 1000 ml. You have to find out the percentage. So, you have to multiply with the 100. So, 53.46 divided by 1000 into 100. You are getting the percentage of acetic acid in the given vinegar as W bar V equal to 5.346 percentage. Final result. In the experiment, we performed the evaluation of the percentage of acetic acid in the given vinegar, and we got this result, that is percentage of acetic acid W bar V in the given sample of vinegar is equal to 5.346 percentage. Thus, we have performed the estimation of acetic acid in vinegar. That all about the present experiment. Have a nice learning experience. Thank you.